So this is a question. Small m is mass of the bar, capital M is mass of the wedge, alpha is the wedge angle, all known. All surfaces are smooth and pulleys are frictionless. Find acceleration of the wedge. So we can assume the acceleration of the wedge to be A. Obviously, it will accelerate towards the right. So you can write that let A be acceleration of the wedge. Now, so if you look from the wedge frame, we can calculate the acceleration of the bar relative to the wedge. So that's the pulley. Bring the wedge to rest. That's the wedge frame. So the wall will come at towards the left with an acceleration A, and as it is attached to the same string, the bar will also accelerate downwards with A. So this A, I mean this vector is the acceleration of the bar with respect to the wedge. And now let's look at the forces that are acting on the bar and the wedge. So first we'll apply Newton's law on the bar. So that is weight of the bar. So we can resolve into the components. So first I'll draw the forces. Separately I'll draw the free body diagram. So that is normal reaction, that is tension T, and if you look from the wedge frame, there will be a pseudo force to the left, ma, because the acceleration of the wedge is A towards the right. Now we will draw this and draw the bar and write the equations or apply Newton's law. So we have determined that we'll work with this x-axis and the y-axis. Y-axis is perpendicular to the wedge surface. X-axis is parallel to the wedge surface. So let's straight away draw the components. So that's mg cosine alpha. This component here will be mg sine of alpha, and there upward you have normal reaction. Now the components of the pseudo force that will come. So that's ma cosine alpha here, and the vertical and the upward component perpendicular to the inclined surface is ma sine alpha. So due to all this, there is the acceleration A. So acceleration along the x-axis way A and the y-axis is 0. Remember, we are looking from the wedge frame. So we can write, okay, I missed out tension, right? Tension T also here. So ma cos alpha plus mg sin alpha minus T is equal to ma. Let's write this equation 1. This is for the x-axis, and for the y-axis, n normal reaction plus ma sin alpha is equal to mg cosine alpha. Name this equation 2. Here we will apply Newton's law for the wedge. So let's resolve into components, and we will apply Newton's law in the horizontal direction, the axis shown. Vertically the wedge is at rest. So let's resolve the forces. So that's equal to n sine of alpha and downward n cos alpha. We are not concerned with that. And again T, this component is T cosine alpha, downward is T sine alpha. We don't need that. So Newton's law for the wedge in the horizontal direction, T minus T cosine alpha plus n sine alpha is equal to m capital M times A. So let's name this equation 3. And now from equations 1, 2 and 3 you have to find out A. From equations 1, 2 and 3 you have to eliminate which one, 3 equations, eliminate T and N and find out A. So just see what I have done, that from equation 1 you find out T in terms of A, and from equation 2 find out N in terms of A and substitute in equation 3. Then after this tiresome calculation you get this answer.